Alright, functions classes, we went ahead and moved on today and we did solving rational expressions. So I'm going to show you some stuff that's going to work for solving. So let's go to it. So equations with rational expressions. First, we're going to continue to determine the domain of the variable in the rational expression. So we have to find the domain. We've been practicing that. We're going to continue to do that. We're also going to solve the rational expressions. And then we're going to take those answers and we're going to plug them back into the original to make sure they actually work. This is something that we don't do a lot. It is something that I mix up a lot, so I want to make sure that you guys catch me in class and you say, hey, wait, we got to make sure that we check our answers. So a rational equation is just an equation that contains at least one rational expression with a variable in the denominator. So basically this is a fancy way of saying we have a variable in the denominator, which is what we've been dealing with. So this is going to be our first example. I feel like that this should be fairly easy. This is something that we've been comfortable with. We've been finding the domain for everything. So the first thing we want to do is find that lowest common denominator. So we're going to start with that first fraction, and we have an x, and then we have a 4. And then 4x is already represented, and I can rewrite that as 4x. I'm going to take that and set it not equal to 0. Divide by 4, divide by 4. And I get that my domain is all real numbers such that x does not equal 0. Then we're going to do the same for this. So go ahead and get this in your notes. Again, just like we would be doing before, even with this equal sign, we're going to want to factor that first fraction. So we're going to end up with 2. And that's a difference of squares. So I know that's going to be x plus 2, x minus 2 automatically. 1 over x plus 2 equals 1 over x minus 2. Okay, again, just like before, I'm going to state my lowest common denominator. I have an x plus 2 and an x minus 2. And then x plus 2 is already taken care of here, and x minus 2 is already taken care of here. So that is my lowest common denominator. Then I'm going to set each one of those not equal to 0 and solve. And I end up with the domain is all real numbers such that x does not equal a negative 2 or a positive 2. So that should feel comfortable. That should feel very familiar. So when we're thinking about solving, so this is solving when we're looking at something with an equal sign. We have an equal sign. So all of the strategies I'm going to teach you today only work with an equal sign. If we try to use this while we're simplifying, we're going to make things far more difficult for us, and it's not going to be good. So this works with an equal sign, so for solving only. So the easiest way to solve most rational equations is to multiply all terms in the equation by the least common denominator, that LCD. Then it says this step will take care of all of the denominators, and so then we don't have them anymore. But it is really important that we verify. So the best way to sum up this last sentence is take your solutions, plug them back in, and make sure they work. Again, this is so important and so missed and so often overthought, like it's an afterthought kind of a thing, that it is incredibly important that we remember that even though we're multiplying both sides of the equation by a variable, one of those answers might not work. Our solution might not be an answer. It may have no solution. So today we're going to start with some simple ones, and we'll go into the more complicated ones tomorrow. Alright, so for this one, go ahead and get this in your notes. I'm going to factor this 20, and I'm going to factor it with a 4, because I can see that I have a 4 right here. So I'm going to have my lowest common denominator is going to be 4 times 5, that's the 20. Then I have an x, and then I have the 4 represented right there, and the x right there. A lot of times if we don't do that, and you didn't have to, this is just something that I like to do, we could have just said that it's 20x, which these two things say the same thing, they're equivalent, they say the same thing. So I could say that, but I might miss that the 4 is inside the 20. You know what I'm saying? So we want to be really careful with that. So then again, I want to find that domain. So I know it's going to be all real numbers such that oops, I don't know why I did an x down there, such that x does not equal something. So we're going to set that not equal to 0, divide by 20, divide by 20, and I get such that x cannot be 0. Alright, here's what we're going to do. I'm going to take my lowest common denominator, or least common denominator, I'm going to take that one, and I'm going to multiply it everywhere. So, I'm going to take 4 times 5 times x times, I'm going to move this negative up here, so negative 3, and I'm going to have that, this part is all over 1, and we're multiplying, and this was over 20. Okay, or I could leave that factored out because we've been factoring our denominators, right? So I'm going to factor my 20. So I'm going to say all over 4 times 5. And that's going to be, oops, and this is all going to be over 1. So this right here is my least common denominator. That's right there, multiplying. Then I have my plus, and I'm going to do it all over again. I'm going to do 4 times 5 times x times 2. This one's all over 1, and this one's over x. Okay? And it's all going to equal, I'm going to do it again, 4 times 5 times x over 1, all over, so multiplied by 5 over 4x. So I actually could rewrite that, and I might. Let's do that. Let's rewrite that. Because it's really 4 times x, right? We talked about that in class. Okay, so if this is all multiplication, I can look for those big ones. Well, I have a 1 here. I have a 1 here. And I'm just left with negative 3x over 1. Anything over 1 is itself, so I have negative 3x. Then I look at this, oh, I've got a big one right here. So then I have, what's left is 4 times 5, which is 20. 20 times 2 is 40, so plus 40. And I have a 1 right there, and a 1 right there, and I'm left with 5 times 5 over 1 equals 25. Boom! That looks like an equation I know how to solve right off the bat. So I'm going to subtract 40 from both sides. I get negative 3x is equal to negative 15, divide by negative 3, divide by negative 3, and I get x is equal to a positive 5. Boom. Now I can check. I have an excluded value. X can't equal 0. Does x equal 0? No, it's a 5. I'm going to go ahead and I'm going to plug it into the next equation. So this is just all the work that we just did. So I'm going to take that original equation and I'm going to check it. So everywhere I see an x, I'm going to put in my proposed solution. Okay, so do you see the blue 5s? So right here. So I'm going to do that, and I end up with negative 3 over 20 plus 2/5 equals 5/20. So when we add and subtract fractions, we have to have a common denominator. That is what we're going to have. 20 is in 2 of those fractions, so I'm going to make sure that next one is a 20. So I multiplied this by 4, both top and bottom. So 4 times 2 is 8, 4 times 5 is 20. So I've got that. And I end up with negative 3 plus 8 is 5 over 20. So 5/20 equals 5/20. Is that correct? It is. I could simplify and say 4 over 4, 4 equals 4. Either way, this works. So I know it works. Alright, so the solution set is going to be 5. We are good. Alright, so now we're going to do the same thing. Oh, this is the warm-up for tomorrow. So that is my last example today. I will go into more complicated cases tomorrow. And if you have any questions, you can either ask me or Miss Wadley. I hope you have a great day, and see you all later.